Hi, let's look into functions in Go. We have been using main function from the start of our course. This is the starting point of every Go program. It doesn't take any parameters, neither does it return any value. Let us look at a declaration where the function will have both parameters and return values. As you can see, a function will use func keyword. Starts with func keyword, function name, parameters, type, and the return type. We use the return keyword for returning the value. Let's call the function. I'm storing the return value of this function in x. Let's print it. Few things that Go doesn't have is named and optional input parameters. If you want to emulate a named and optional parameter, then you can define a struct that contains those fields that match your desired parameters and pass the struct to your function. Let's see a basic example for that. Let's declare a struct person. Now to this example function, I can pass only first name and age. These will be the default values for first name and age, and inside the function example I can change those values. You can see I made it optional by omitting last name. Yeah, that's how we can use it. Let's look at variadic input parameters in functions. This should be the last or only parameter in input parameter list, indicated by three dots followed by the type. Within the function, a slice of that type is created. Now let's look at an example. This is a function which adds base value to any number of parameters. You can see here I used a variadic input parameter, which means it takes any number of parameters. I made a slice out which has the capacity of length of parameters. I passed. Next, I'm iterating over it and adding the base value to it. I'm returning the out slice. In the first one, you see I passed only the base value. The length of vals will be 0 and we will return a nil slice. Next, I passed only one value here and we'll have 3 plus 2 and 5. That's the value of slice. Next, I passed 4 and each one will be incremented by 3. As I said before, this will create a slice internally. So I can pass a slice. Don't forget to use 3 dot operator after A. If you won't use it, it will throw a compile time error. This will be incremented by 3. And here also I'm passing a slice of type int with 5 values, and you can see it's followed by 3 dots, and yeah, they will be incremented by 3. Next, let's look at multiple return types. If a function returns multiple values, you must return all of them separated by comma. In the function here, let's also return reminder. If there are more than one return values, then you need to put them in parentheses. Here let it be 0. Why am I getting error here again? Because there are two written values and I'm trying to assign it to only one value here. You might think this might turn into a slice and take the values. No, that's not possible. You need to use both the variables. Oh, 3 and 0. If you don't want to use it, you can just use an underscore. That's valid. This will support to return an error if something goes wrong in the function. So I can return a error. If there is no error, I can just return nil. I can check error variable to see if there is any error written by the function. Let's pass 0 as denominator. Okay, denominator can't be 0. I previously said that you need to take all written values of the function, but Go lets you implicitly ignore all the written values for a function. That means either you take all or take none. Yeah, that's valid in Go. Now let's look at named written values. We must surround named written values with parentheses even if there is only a single written value. Previously, if there was only one value, I didn't use any parentheses, but if I give names, I need to use parentheses even if it is only one. Let's give it the name of result, reminder, error, and you can basically assign values to them. Let's try executing this. Yeah. Next you see they're initialized to their 0 values. So I can just return result because the 0 value of int is 0. Assign error with this one. Return error. Yeah. Let's run the program. Let's pass 0. Yep, it worked. One thing to look into while using named written values is problem of shadowing. I declared result here to be some other value and returned it. Let's see the output. Yeah, it's 10, but it should be 0, right? So that's the problem of shadowing. We should be careful with that. We don't necessarily have to return them. We have something called as blank returns that returns the last values assigned to the named written values. So if I won't return them, it will search for last initialized value of these variables and return those. I can also directly return these values. That's also valid. Next, functions as values. Type of a function is built out of func keyword, types of parameters, and written values. We also call it as the signature of the function. Here are 4 functions and all of them have the same signature. The number of parameters and the type of parameters, type of written values, everything is same for all the 4 functions. And have a map here where I'm assigning these functions as values to those keys. And internally I can access them using this key. You see, 2 is printed. You can access it that way. Next we have function type declaration. Like struct, we use type keyword to define a function type. I can create a function type here, starting with type keyword, name, func, parameter list, return type. Yeah. Instead of using the signature here, I can just give the func. Let's run this. Now let's look at anonymous functions. They don't have any name, neither we need to assign them to any variable. We can write them inline and call them immediately. Here is an anonymous function. It doesn't have name. We follow the func keyword with the parameter list, and you see I called the function just after defining it using parentheses and passing the parameters that it needs. Basically I can also return a value, but it will just iterate for one time and return from here. Printing 0 from inside of anonymous function. I'll make a part 2 for functions where I'll be talking about closures and defer. Thank you.